Hey class, in today's lesson we are going to discuss polynomial functions, which is found in section 5-1, part 2 of your book. Our objective is to graph polynomial functions and describe in behavior. So in our first example, it says, what is the graph of the cubic function below? Alright, so first when we are graphing, what you need to understand is that in order to graph, we need to kind of like when we were doing quadratic functions, we need to determine what the vertex was. And that would kind of help us start with where we're supposed to start for our table. And so in this case, if you think about it, 1/2 compresses our graph. So, but it hasn't shifted left nor right. So we're just going to assume that our vertex is at 0. So if that's the case, then when we create our table, 0 will be in the center. I'll pick 1 and 2. And also -1 and -2. And actually, let me back up, because remember, when we have a fraction, we want to use the multiples of the denominator. So I'm actually going to use 2 and 4, and then -2 and -4. So we know if we put in 0, 0 cubed is 0, and then times 1/2 is 0. But let's try 2. 2 cubed, which is 2 times 2 times 2 is 8. Then 8 divided by 2, or times 1/2, is 4. So this is 4, and that's going to be 4. Next, if I type in 4, 4 cubed, or 4 times 4 times 4, well, 4 times 4 is 16, and 16 times 4 is, I believe, 64. And then if I divide that by 2, that's going to give me 32. So those are really huge numbers. I probably should have chosen something smaller, but that's okay. So next, we would graph. And we can verify all this information using a graphing calculator. So since 32 is fairly large, I'm going to count by 5s. So 5, 10, 15, 20, 25, 30, 35. So this is nowhere near as accurate as I normally am, but that's okay. So -4, +32 is going to be about here. -2, +4 is about here. 0, 0, we know where that is. The next one will be about here, and then below, right about there. So our graph will actually look like that. And in this case, it almost looks like it's stretched, but it's actually not stretched. It's just because that 32 kind of extends our graph, so it makes it look really, really stretched when really it's compressed. And so we're done with example 3. Also, if you remember, we talked about, or turning points is technically a part of this section. And so the amount of turning points that we should see is 2, because our highest power is cubed, and the amount of turning points is the highest power minus 1. So we should see 2 turning points, and we see them here and here. All right, so let's keep going. All right, in try 3, we need to, first of all, put that in standard form, because right now it's not in standard form. So really it's y equals -x cubed plus 2x. Again, on this one, there's no really clear indicator of what our vertex is, or the center of our graph. So we're just going to use 0 as our starting place. And so we'll use values to surround it. So 1 and 2, and -1 and -2. So if I substitute in 0, 0 is going to be 1. 0 is going to be 0. If I substitute in 1, that's 1 cubed, which is 1, times a negative, which is -1. Plus 2 times 1, which is 2. So that's going to make our answer 1. And actually, I'm making the assumption that it's going to be 1 on the other side. And the only way I can make that assumption is if it is, if 0, 0 technically is the center. So let's go ahead and make sure that it is. So if I substitute in -1, that's really like -1 cubed plus 2 times -1. And so I think we're going to get a different answer. So -1 cubed is going to be -1. And then -1 times the negative is +1. Minus 2 gives us actually -1. So I was incorrect. So it's a good thing that we went back and checked that. So again, 0, 0 is technically not our center here. All right, if we keep going, if I substitute in 2, that's going to be -2 cubed plus 2 times 2. 2 cubed is 8, so that's negative 8 plus 4, which is negative 4. So let's try negative 2. That's going to be negative 2 cubed plus 2 times negative 2. That's going to give us negative 8 minus 4. That's really 8 minus 4, which is positive 4. So I need to erase this information to the side so that I can do my graph. All right, so here we go. That's negative 2, positive 4, then negative 1, 0, 0, 1, 1, and then 2, negative 4. And so what this graph is going to form is this shape here. And that actually makes sense because once again, this cube tells me that there are 3 minus 1 turning points. So there are 2 turning points, and that's what we see. There's a turning point here and a turning point there. Example 4, now we're using the differences to determine what the degree of our function is. So we do that by checking the differences of your y values. So what's going on from, for example, negative 1, well, if you get confused, try counting between your positive numbers, and that may help. So from 5 to 11, you're adding 6. I mean, actually, that's not going to help because you're going to need to do this quite a while. So here we go. So from negative 1 to negative 7, it is decreasing, so it is subtracting by 6. From negative 7 to negative 3, you're actually increasing, and we added 4 to get there. From 3 to negative 5, we're also increasing, so we're adding 8. Already did from 5 to 11, that's 6. 11 to 9, we're decreasing, so that's minus 2. And 9 to negative 7, again, we're decreasing, and that would be, let's see, that would be negative 16. Okay? From there, we need to continue to find the differences. So if all of my differences on this level had been the same, then this would have been to a degree of 1, which would have meant that everything was linear. And that's not the case here. So not linear. All right, let's try again. So from negative 6 to positive 4, I'm increasing by 10. From 4 to 8, I'm increasing by 4. From 8 to 6, I am decreasing by 2. From 6 to negative 2, I am decreasing by 8. And from negative 2 to negative 16, I am decreasing by 14. So if it had been all the same here, then it would have been a degree of 2, which would have meant that it's quadratic, but it's not. So not quadratic. All right, so let's try again. So from 10 to 6, I'm decreasing by 6. From 4 to negative 2, I am decreasing by 6. From 2 to negative 8, I'm decreasing by 6. And from negative 8 to negative 14, I'm decreasing by negative 6. So again, at this point, they are all the same, which is wonderful for us because that lets us know that it's going to be a degree of 3. And so if it's a degree of 3, that means it's going to be a cubic function. So based on looking at the values of y, I can determine that this function is going to be cubic. All right, so we're going to do the same thing on try 4. All right, so let's state our differences. So from 23 to negative 16, we're decreasing. Let's see, that's decreasing by negative 39. From negative 16 to negative 15, we're increasing by 1. From negative 15 to negative 10, we're increasing by 5. From negative 10 to negative 13, we are decreasing by 3. From negative 13 to negative 12, we are increasing by 1. And from negative 12 to positive 29, we are increasing by 41. All right, so moving on past that. So it's obviously not linear, so we need to keep going. So from negative 39 to positive 1, we're increasing by 40. From 1 to 5, we're increasing by 4. From 5 to negative 3, we are decreasing by 8. From negative 3 to 1, we are increasing by 4. And from 1 to 41, we're increasing by 40. So it's not quadratic. So let's try this again. So from 40 to 4, we are decreasing by 36. From 4 to negative 8, we are decreasing by 12. From negative 8 to positive 4, we are increasing by 12. And last, from 4 to 40, we are increasing by 36. So it's not cubic either. So let's try this one more time. From negative 36 to negative 12, so I need to pick a new color, and I know you're not going to see it, but I'll do it out to the side. So from negative 36 to negative 12, we are increasing by 24. From negative 12 to 12, we're increasing by 24. And from 12 to 36, we're increasing by 24. So this is not first degree, second degree, or third degree. This is fourth degree. So this is a fourth degree polynomial function. And guys, that's it. Remember, if you have any questions, come see me for tutoring.